In this video, we will see code implementation. So now let's check out how we can solve this question. So if we talk about the approach 1 question, okay, so we should not discuss because but like that is a brute force approach. Okay, I have already given the hint for it. Okay, so we can move to the approach 2 because approach 1 is simple, clear. Okay, but like if let's see, it won't take too much time. So let me quickly give a pseudo code for it. So I will start from 0 to n, and then we will have a j loop that will start from I plus 1 to n, and then we will have one loop that will start from k is equals to I plus 1 to n. Okay, and after this, okay, we will check if so let's suppose our array is nums. So nums is my array. So if nums of I plus nums of j plus nums of k is equals to 0, right? If this is the case, so I will have a triplet, right? So I will have a triplet is equals to nums of I, comma nums of j, comma nums of k. This will be my triplet. And then what I will do, I will just check, or you can say I will sort my triplet. I will sort my triplet, and after sorting, I will just check that if it is present in the object, that is triplet. Okay, if it is not present, so what I will do, I will make it present. So I will simply say object triplet equals to 1. Okay, and I will push into my answer array. So answer dot push triplet. Okay, so before this, what I will do, I should create an object. So that will be one object, and that will be one answer. Okay, answer array. Okay, so this will be your approach 1. Basically, by this you will get a complete if not present. So would not in the object, you will define in the object, you will push in the answer. In the last, you can simply return your answer array. Okay, but we have already discussed the time and space complexity of it. Okay, now let's check out the next approach that we have checked, approach 2. So in approach 2, what we have done, okay, so we have sort the array because we need to apply the 2-pointer approach. Approach 2, it's dependent on 2-pointer approach. Okay, so we will sort the array. So I will simply say nums dot sort. Okay, to sort the elements. You can use any method, right? In Java, there are different methods. Arrays dot sort, you can apply that. And let's take one answer array. Let's take again the same object. Okay, and let's start for I is equals to 0 to n. I will again move, and then inside it I will apply the 2 pointers. So I will have one pointer L that will be I plus 1, and I will have one R pointer that will be n minus 1, always be the last element. And let's suppose n is here, capital N. Okay, so L pointer is done, R pointer is done. Okay, and now what we will do, we will simply apply 2-pointer approach. How? Okay, so we will see in while loop, while L is less than R. Okay, if so I have 3 elements. If nums of I plus nums of L plus nums of R, this is going to be 0, right? So what I will do, I will again store all these values in triplet. Let me quickly copy this. I will add all these values in my triplet. This will be L, this will be R. Okay, and after this, what I will do, I will check that if again is it present in my object or not. So I will check if object of triplet is present or not, right? So if it is not present, what I will do, I will define it completely same. I will define it and I will push into my answer array. So I will define it and I will push into my answer array. So this will be our approach 2, right? Short, a bit short, a simple. Okay, but what was the repetition that we were doing here? Okay, again, right, let me write that condition where this condition won't met, right? So if this condition is not meeting, okay, so we will have, like, suppose the whole sum, that is nums of I plus nums of j plus nums of k, will be less than 0. Okay, so if this is the case, what we will do, we will do L plus plus. Else one case will be that it should be greater than zeros, then we will do R minus 1, right? And after this complete for loop, okay, I will return the answer array that I have created here. So this will be our approach to. Now, what were the repetition? Repetition was that we were creating a triplet, we were checking in that, like, is it present or not? Okay, so we can simply ignore this step. How? So let me copy this complete and put in approach 2. So I will copy this and I will put in approach, let me see, 3, same approach, just a little modification I will say. Okay, I have sorted array, we need to sort it, answer, we need to define, start with I0 to 1, like n completely. But again here we can add one condition, that if my I is greater than 0, that it should not be 0th element. Okay, it is greater than 0 and my nums of I is exactly equals to the last num that I have encountered, that nums of I minus 1. Okay, what I will do? I will simply continue. I will move forward. I won't come inside here, right? I will continue. I will simply do I plus plus. So this is the condition that I have added. Okay, and here now we were checking the object. We don't need to check the object. Okay, I forgot one thing, right? When the two things, right? When these two, like when we get the object, what we need to do? We need to do L plus plus and we need to do R minus, because we find it, right? So we found out the solution. Okay, then we need to move forward. So it will be L plus plus and R minus 1. Okay, so again you can check here, we are doing in this if condition, we are doing L plus plus R minus minus. If it is less than 0, we are doing only L plus plus, because we need to increase the sum. If it is greater than 0, we are doing R minus minus. Okay, now here this will be, again this will be also same, right? Here you are in this condition, so here also you will do L plus plus and R minus minus, but we won't come under the object part because we are always taking the unique elements. How? So suppose we got a triplet here. Okay, we got a triplet. Okay, I will put one condition, while while if I am encountering the same element, nums of L, is equals to nums of L minus 1, what I will do, I will simply move forward. Okay, I will simply move forward, and same here. Okay, if nums of R is equals to R plus 1, my R pointer will simply move R minus minus. So now let me quickly move this L pointer here, plus plus and R minus minus, and we will, like, if we are encountering the same element, we will simply move it here. But when we are moving, we need to check, like, we should be always, this condition should always be true, that L should be less than R. So I will mention this with AND condition, right? So here I got the triplet, I will simply store in my answer dot push the triplet, nothing to do. Okay, so this will be our approach. We basically, again, let me give a quick overview of it. So we will simply sort it. We will simply then, after sorting, we will create two things. Now we don't need to create an object. We'll simply create an answer array. We'll start with I. We'll take if my I is greater than 0 and nums of I is equals to nums of I minus 1. We will simply move on. Okay. We'll take two pointers, L, I plus 1, R, N minus 1, and we will check is L is less than R. We will check if it is satisfying the condition of triplet. Yes, it is. We will simply push it to my answer, right? You can simply ignore this step. You can simply push it in the answer. We are not checking anything. Okay, I will move both the pointer. But after moving both the pointer, again the element are same, right? So I will do L plus plus, I will do R minus minus. Okay, again here if the elements are same, we will simply again do L++ and R minus minus, and eventually we will get the answer. So in the next video, we will check out how we will get the complete understanding of this. We will do a small amount of a dry run. Okay, then you will get a complete understanding how this approach is working. Okay, so see you in the next video.